Okay, we're doing another parametric equations question. This time, we're going to be differentiating the parametric equation to find the equation of a tangent or a normal. Okay? So we're given our parametric equation, x is 2 cos t, y is root 3 cos 2t. It says, firstly, find an expression for dy by dx. So the expression you're going to need to learn, or the formula you're going to need to learn for the derivative of a parametric equation is dy by dx is equal to dy by dt divided by dx by dt. Okay. Two ways you could learn this formula. Skip ahead 1 minute if you already know this really well, but one way you can memorize it is by the fact that you do the chain rule, the way you kind of link variables together. So we've talked about this before. You can, obviously we only have y in terms of t here, so dy by dx is going to be equal to, I'll make it dy by dt because I can find that, and to complete this equation, make it make sense, I have to have a dt by dx, right? And the dt's will cancel. And here what I'm doing is I'm taking dy by dt and I'm multiplying by the derivative, by the reciprocal. I'm multiplying by the reciprocal of dx by dt, which is the same as dividing by dx by dt. That is how you divide fractions. Another way you could remember this rule is a bit more simple. It's just like numerical fractions, right? If you have something like 7/11 divided by 10/11, you are able to multiply the numerator and denominator of this fraction by 11. 7/11 times 11 is just 7. 10/11 times 11 is just 10. And what's actually happened is the divide by 11 have just cancelled off, and we're left with 7/10. Same way up here, dy by dt divided by dx by dt, you could multiply top and bottom by dt and just get dy by dx. Okay, so that's why the formula works. That's how you can remember it. Okay, let's get rid of this and compute this derivative. So we know y in terms of t, we know y is root 3 cos 2t, we know x in terms of t, so we can just calculate these derivatives as we just would differentiate normally, right? Okay, so dy by dt is going to be negative 2 root 3 sine 2t, and dx by dt negative 2 sine t. So first of all, I can cancel off those 2's or negative 2's. If you leave your answer as root 3 sine 2t over sine t, you can get full marks in this case. You might spot there is something you can do here. Sine 2t is equal to 2 sine t cos t. So the 2 here is coming from the double angle formula. And then this is good because this will cancel off with the sine t on the denominator. Now, in this case, the final answer for dy by dx would be, what's that, 2 root 3 cos t. This would also get you your full marks. Technically, this is only allowed if sine t is not equal to 0. You can't cancel off a factor that's 0. So this only works if t is not equal to 0 or pi. Both of those values of t are actually considered in our parametric equation. Yeah. At A level, you're not going to be asked to evaluate the derivative, evaluate this thing here. You're not going to be asked to evaluate that when t is either 0 or when t is pi. Okay, if you're doing further maths with L'Hopital's rule, then yes, but for us, we're not, which is why the mark scheme will accept either answer. We're going to take this answer because it's a bit more simple. Okay, we've got our derivative. Let's answer part B. I'll do part B up here. So part B says point P lies on the curve. L is the normal. It wants us to find the equation of L, so the equation of the normal to the curve. Let's kind of draw this curve in. I don't know how it looks, doesn't really matter. Let's say that this here is point P. Let's do it like this. And we have to find the equation of the normal, so the normal goes like this. Okay. The way you find the normal to a curve, whether it's parametric or not, it's the same idea, right? You find the gradient of the curve at that point, and the negative reciprocal will give you the gradient of your normal, your straight line. And then once you know the gradient of your straight line, you just need the coordinates of the point it goes through, so the coordinates of P, and then we can use that to find the full equation of the line. So let's start with the gradient. We know an expression for the derivative of this curve. Yeah, derivative of this curve is given by, we just figured it out, right? It was 2 root 3 cos t. And P was the point where t is 2 pi by 3. So when you have a parametric equation, your points will be described not in terms of their x and y, right? They can be described in terms of what's the value of t at that point. Well, that's good. We know dy by dx in terms of t as well. So when t is 2 pi by 3, dy by dx, you can just calculate it. Cos 2 pi by 3 is negative 1/2. So this is negative root 3. Now remember, this gives us the gradient of the curve, right? This would be the gradient of this line. Because we're doing the normal, like you did in year 12, you're going to take the negative reciprocal. Negative reciprocal of negative root 3 will be 1 over root 3, or you could write root 3 over 3. Okay. Now, secondly, when you need the equation of a straight line, you need a point it goes through. So we're going to need the coordinate of point P. What we know about P is we know t is 2 pi by 3, and we actually know x and y both in terms of t. So if t is 2 pi by 3, x is 2 cos t, so 2 cos 2 pi by 3. Y is root 3 cos 2t. 2t here, right, would be 4 pi by 3. Right, so cos 2 pi by 3 is negative 1/2. Cos 4 pi by 3 is also negative 1/2 actually. So here's the coordinates of our point P. Here's our gradient. We can just use those to calculate our straight line. Okay, I'll keep working down the page. So just draw a little line here. You can use y minus y1 equals mx minus x1. I'm just going to use y equals mx plus c. We know m was root 3 over 3. And we can sub in our point P to find the value of that c. So this should be pretty quick. If you're revising, differentiating parametric equations, I hope by this point you've mastered substituting to find the value of c in y equals mx plus c, right? So be very quick when you add this over. You're going to get root 3 over 2 minus, sorry, that's root 3 over 3 minus root 3 over 2, which will give you negative root 3 over 6. So putting that back in, y is root 3 over 3x, take away root 3 over 6. And the question does have to give a straight line, yeah, in this form here. 2x take away 2 root 3y take away 1 equals 0. I noticed that the coefficient of x is positive here. So what I'm going to do is first multiply by 6. But then when I take everything over to one side, I'll take it over to the right side, so I can keep that positive coefficient of x. Now the coefficient of x that it was asking for was 2. I have 2 root 3. So I need to divide everything through by root 3, just to make sure. So I thought my equals 0 here, didn't I? Just to make sure it matches what I'm asked for. 2 root 3 divided by root 3 is 2. 6 divided by root 3, well, do that any way you like, rationalize the denominator or whatever, put in your calculator. It's 2 root 3. And this is exactly what was asked of us in the question. Okay, 2x take away 2 root 3, take away 1 equals 0. There we go. Okay, final part says the line L intersects the curve again at point Q. Find the coordinates of Q. Right, so part C down here got some kind of line. Let's say here was P, and then the line P actually the tangent, the normal, intersects again at Q. So we're going to substitute in and solve for when the straight line, which is 2x take away 2 root 3, take away 2 root 3y, take away 1 equals 0. When does that meet the curve? And here's the best way usually to find the intersection of a parametric curve or a parametric equation and a Cartesian equation. Okay, so a Cartesian equation, by the way, if you're not sure, that's when your equation is given just in terms of x and y only, right? So my line L, this one here, this is a Cartesian equation because there's only x's and y's, whereas my curve C is given by parametric equations, right, with x's and with y's, and t's, sorry, with a t. So when you have a parametric and a Cartesian, what you can do is you substitute in the parametric equations into your Cartesian equations. Sub the parametric equations into the Cartesian. So what do I mean by that? What I mean is my parametric was that x was, remind ourselves, x was 2 cos t, y is root 3 cos 2t. Okay. So you can substitute these in to the Cartesian equation you have. Our Cartesian equation was our line 2x, take away 2 root 3 y, take away 1 equals 0. So x is equal to 2 cos t. 2 cos t, not cos t. 2 times x. Take away 2 root 3 times y, with root 3 cos 2t. Take away 1 equals 0. Now, what this will give you is an equation for t. So you will use that to find t, and once you know t, you can then find x and y, again, based on your parametric equations. Okay, so intersection of parametric and Cartesian, you're going to substitute in your parametric expressions into your Cartesian and just get an equation for t. It's usually the easiest way to go. So we've done that. Let's actually just solve for t now. So 4 cos t, root 3 times root 3 is 3, so that's 6 cos 2t. Take away 1 equals 0. This equation is a little bit tricky because it's cos t and cos 2t. So you're going to need to use some kind of identity to change your cos 2t into something with just t. And with the double angle formula for cos, you've actually got multiple options. You're going to want to select the option 2 cos squared t take away 1. Reason being that once you do that, your equation only has cos, it doesn't have cos and sine, right? And then hopefully you can recognize at this stage what you're going to get is a disguised quadratic. Okay, so this is something from year 12, solve an equation, something like this, where it's in terms of cos t and cos squared t. So let's expand that all out. 4 cos t take away 12 cos squared t. This will be plus 6 take away 1, so that's plus 5 equals 0. And we get a disguised quadratic. We'll make the cos squared term positive. So let's take everything over. And then, do a u sub or a y or x or whatever. Use your calculator to solve the quadratic or factorize to solve the quadratic. I think if you factorize here, 6 cos t, take away 5, and 2 cos t plus 1 equals 0. Okay. First bracket will tell you that 6 cos t take away 5 equals 0, so cos t is 5 over 6. Second bracket will tell us that cos t is negative 1 over 2. So it looks like I actually have 2 intersection points of my line and my curve, which, if you go back and look at your picture, right, all this algebraic equation is doing is telling us at which point does the line meet the curve. So of course there are 2 solutions, right? There is P and there is Q. Yeah, we would definitely expect that. So one of these solutions will lead to the point P and one will lead to the point Q. Now, if you take cos t equals negative 1/2 and take the inverse cos, t is going to equal to 2 pi by 3. This is a point P. Okay? So this point over here must be Q. So you might want to try, okay, let's do the same thing. Let's take inverse cos. Turns out, I put my calculator in radians here and do the inverse cos of 5 over 6. That's not going to be anything nice. Okay, 0.5856, blah, blah, blah. Okay, 0.586. And so on. Remember, this is not answering the full question. We found the value of t. Yeah, it wants the coordinates of q. You need to go back in and find x and y. So I'm going to use our relations here. X is 2 cos t, y is root 3 cos 2t. So x is going to be 2 cos t. Now what you want to do here, you don't want to substitute in this into t and take the cos again, right? We already have an expression for cos t. We know cos t is exactly, no rounding, 5 pi by 6. Exactly 5 pi by 6. Okay, so x is 2 times cos t. That's going to be 2 times 5 pi by 6. Sorry, just 5 over 6. Which is, what's that? 5 over 3. Now y, similar thing here, y was root 3 cos 2t. Now what you don't want to do is substitute, even if you use the exact value from your calculator, okay? Even if you store the answer or you use the answer key and you sub in, your calculator may give you the exact solution, but you've not fully shown your working. Okay, this question says, what did it say? You must show clearly how you obtained your answers at the bottom there. So, given that I know that cos t is 5/6, you can find exactly what cos 2t is using the same identity we did earlier. Yeah, cos 2t is 2 cos squared t, take away 1. So it's up here. So 2 times, now cos t was 5/6, and then squaring it, and then taking away 1. Now multiplying this through, you can use the calculator now, right? This is 25/36 times 2, so 25/18, take away 1 is 7/18. So y is going to be 7 root 3/18. I've got y, I've got x, so q is x, 5/3, comma, y, 7 root 3/18. Right, so I found my exact value of cos 2t based on what cos t was. Algebraically, yeah, I didn't just type in cos of 2 of inverse cos of 5/6. That's not going to cut it for fully showing your working. What you can do is use the calculator to at least check your answer though. Okay, so hopefully a question like this is now going to be pretty straightforward. It's a fairly straightforward process of calculating the derivative, and then the normal is just what you do for a normal year 12 question when you find the normal. Yeah, I don't know why I keep scrolling down. You find the derivative and you substitute in your values of x and y based on t, and then you go from there. And then for the Cartesian line intersecting the parametric curve, we said that you're going to want to substitute in your parametric equations, which have a t in them, straight into your Cartesian equation, and that should give you an equation to find t. And then from there, it should all be good. Okay, so hopefully that's all good, and let me know any questions.